Hello, everyone, and welcome to another episode of It's Your Grade. I am your host, Sarah. Today's video will be a very short introductory video about the difference between ionic and covalent bonds, and there will be later videos that will focus on each of them individually. So to start, an ionic bond is an electrostatic attraction between ions. And these ions are typically metals and nonmetals, but it could be metals and polyatomic ions, or you could have a positive polyatomic ion and a negative polyatomic ion. And we'll learn more about those in later videos. So we have an electrostatic attraction between ions. Conversely, a covalent bond is when you have equal sharing of electrons between atoms. For ionic electrostatic attraction between ions, an example of this would be sodium chloride, your table salt. And sodium chloride is composed of a sodium ion where the sodium metal has lost an electron, and a chloride ion which has gained an electron. So we have a sodium plus ion and a chloride -1 ion. And these ions sort of just hang out together in some sort of crystal lattice. There are other examples of ionic compounds, and we'll learn more about those in later videos. But as an example, if you like to take Epsom salt baths, this is something called magnesium sulfate. And magnesium sulfate is composed of a magnesium ion and a sulfate ion, where sulfate is a polyatomic ion. If you've ever heard of rust, I'm sure you have, that's known as iron oxide. Sorry, Fe2O3 is the correct formula. So this would be iron 3 oxide. And once again, we're going to learn how to name ionic compounds, how to put together these ionic formula in later videos, but just as an example, those are ionic compounds. And they all form ionic bonds, which is an electrostatic attraction between ions. For covalent bonds, as we suggested, it's an equal sharing of electrons between atoms. And the most common covalent compound or molecule that you will experience, it makes up 70% of the human body, and that is water, H2O. And in later videos, we will also learn how to do Lewis structures, which allow us to know how the electrons go together with atoms to form these types of structures, as I've drawn here for water. So the bond between the hydrogen atom and the oxygen atom, that is your covalent bond. And the oxygen and the hydrogen are equally sharing electrons, where a covalent bond is composed of 2 electrons. Other examples of covalent compounds, we breathe out CO2, carbon dioxide, and its structure looks like this. We also have oxygen, or O2, that we breathe in, its covalent structure or covalent molecule looks like this. And there's many, many covalent molecules that exist in nature and that you'll see in your everyday life. Another familiar one perhaps is methane, CH4, which has this basic structure where the hydrogen atoms are all bonded in a tetrahedral shape. Again, we're going to learn all of these, some of these terms that I'm throwing out, they might be foreign to you now, but they're kind of keywords for future videos, so keep a lookout there. Anyway, that's the basic difference between ionic and covalent bonds. Ionic bonds are an electrostatic attraction between ions, and covalent bonds are an equal sharing of electrons between atoms. Ionic compounds typically are composed of a positive and a negative ion. The positive ions are usually metals, but they can also be polyatomic ions. I didn't actually give an example of that. So one example of that could be ammonium hydroxide, where ammonium is NH4 plus and hydroxide is OH minus. So that's just another example of an ionic compound that you might see. And covalent compounds, covalent bonds are typically formed by the equal sharing of electrons between atoms. And these atoms are typically non-metals. So hydrogen, oxygen, carbon, these are all non-metals. And I might do a video with an overview of the periodic table if you all need some review of where your metals and non-metals and charges and all those sorts of things are on the periodic table. So look out for future videos of that. If you enjoyed this video, please like and subscribe. Leave a comment. I've just getting started with this channel again. It's been sitting dormant for a number of years while I completed my PhD and have moved on in things in life and whatnot. So if you have a request of anything you would like me to discuss, or to teach chemistry wise, just leave a comment, drop a comment, and I'm happy to put together those videos for you. So thank you all for listening, and stay tuned for more videos on It's Your Grade.